Sorry I was sick on Thursday, and I hope that you got my email before you made it to campus. This is some of the material that we would have gone over had you been in class. We've been talking about types of chemical reactions. We talked about synthesis reactions where two substances make one. We talked about decomposition where one substance makes two. We talked about exchange where substances swap partners. We also talked about combustion. The last type of chemical reaction we're going to talk about is the oxidation and reduction. This gets its own section because it's such an important type of reaction. Oxidation and reduction reactions involve one element gaining electrons, whereas another element will lose electrons. The oxidation loses electrons. This will be a metal. The metals will lose electrons. In organic systems, we may see that the substance that's oxidized gains oxygen or loses hydrogen. The substance that's reduced gains electrons. Remember, they're gaining a negative, and so they're reduced. This will be a nonmetal. So again, we'll have to go back to the periodic table and tell which elements are metals and nonmetals. In organic systems, substances that are reduced lose oxygen or gain hydrogen. So in these reactions, one substance is oxidized and the other is reduced. These always go together. You can't gain an electron unless somebody's willing to give one to you, and you can't lose an electron unless you can find somebody who will take it. So let's look at one of our inorganic reactions. Here we have two coppers reacting with oxygen to make a copper 2 oxide. The copper here is our metal, so it will be oxidized. The oxygen will be gaining electrons, and so it will be reduced. We can look at this by kind of expanding this ionic compound and seeing that copper is going to have a positive 2 charge. Oxygen has a minus 2 charge. So what we have is copper going from just regular elemental copper to going to copper with a positive charge. In order for it to do that, it had to lose 2 electrons. For this oxygen to have a negative charge, the elemental oxygen must have gained 2 electrons so that it could be oxygen with a negative charge. We're going to get rid of that. Let's do one at a time. Okay, so the metal has lost electrons and the oxygen gained electrons. So this was oxidized and this was reduced. Okay, we can come down here and look at lithium fluoride. Lithium is our metal. It will be oxidized and it will lose electrons. Fluorine is our nonmetal. It will be reduced and it will be gaining electrons. So we have our lithium is going to make a lithium ion with a positive charge, and it loses an electron to do that. The fluorine has to gain an electron to become that fluoride. So let's see how this works when we get inorganic compounds. Organic compounds. Here we have an aldehyde. An aldehyde is a a carbonyl group, that's a carbon double bonded to an oxygen, that's at the end of the chain. So this carbon is bound to a long chain over here. That's what this R is, the rest of the molecule. And it's bound, double bonded to an oxygen, and it's bound to a hydrogen. It is reduced by adding more hydrogen, and then it becomes an alcohol. As you can see, we've got one hydrogen here, and here now we've got 1, 2, 3 hydrogens. An aldehyde can also be oxidized. Here we've added an oxygen. Here we've got one oxygen, and here we've got 2 oxygens, and that's oxidized to make a carboxylic acid. In the following reaction, determine if the organic reactant, this is benzoic acid, is undergoing oxidation or reduction. Well, what you want to look at to see whether you've got more hydrogens, less hydrogens, more oxygens, or less oxygens. I've got 2 oxygens here and 1 hydrogen. Over here I've got 3 hydrogens and 1 oxygen. So I have fewer oxygens and more hydrogen. And that would indicate that this is a reduction. And this would have to be coupled with another reaction, because you can't have a reduction without having an oxidation as well. So this is kind of, there's also an oxidation going on. It's just not shown. Okay. Let's look at